Light is a wave that oscillates in a direction perpendicular to its direction of travel. Now, it can oscillate in any direction, but a polarizer will only let certain orientations pass through it. If I have two in my hand, the first one is going to dictate the direction of oscillations. If the second polarizer is oriented the same way as the first, it'll let all that light pass through. If it's perpendicular, then it will absorb all that light. Anything in between will rely on the relative angle of these two polarizers. What if I have three? Well, the first one dictates the original direction of oscillations. The second one will let through light depending on its relative angles between 1 and 2, and the third one will let light through depending on its relative angles between 2 and 3. Mathematically, it's straightforward, but it can seem counterintuitive, because if the first and last polarizer are perpendicular to each other, they will block all the light going through them. But somehow, by adding a third polarizer in between, I can start letting light go through them again. To see why this actually works, let's go back to two polarizers oriented, say, 45 degrees from each other. Then half that intensity will be lost. Because we can think of the second polarizer as breaking the first light into two pieces and only letting the one piece through. And I know it feels like the light should remember that it was really going up and down, and it just kind of snuck through the second polarizer. But no, the remaining light is now actually oriented 45 degrees to what it was before. And so once we get to the third polarizer, it sees the light that is 45 degrees, not up and down. And in fact, if we were able to stack an infinite number of these in a row, with only small angles between each layer, we could rotate the light 90 degrees with hardly any loss of intensity, which feels so wrong, but it works so right. Thanks for watching.